Hello and welcome back. In 1.3, we'll do a quick review on linear and quadratic functions. So we'll just do just a few quick things with the linear. Writing the equation of a line given a pair of points. I'll do, I don't know, -5, 3, and what did I pick here? 6, -4. Slope, remember, change in y divided by change in x. So 3 minus a -4. Just watch your sign work there. 1 is from the fact that we are subtracting. 1 is from the fact that we happen to be working with a negative number. Once I choose which y value went first at the top, its partner has to go first at the bottom. So our slope for this one, change in y is +7, change in x is -11. And then solving the slope formula for change in y, just multiply both sides through by change in x, and we get slope is change, or we already had slope equals, we get change in y is our slope times change in x. And we'll get the same answer out of either ordered pair. Hopefully that's all review for you. So y minus 3 is -7/11 of x plus 5, so minus a -5 is +5. If this can be reduced, make sure you reduce it as well. So y is -7/11 of x minus 35/11, and plus 3 over 1 is 33/11. So y is -7/11 of x minus 2/11. So again, hopefully that's review. We'll be working a bit with this idea of change in an amount. Let's see, do a quick supply and demand. So I had $20 per unit of whatever it is we're selling. Supply is 100,000 units. Demand is 80,000 units. And at $16 per unit, supply is 70,000 units. Demand is 100,000 units. So right away, as far as slope, it should make sense. Our price decreased. Cheaper items, you can get an item for cheaper, more people are going to be willing to buy it. If they're not able to sell it for as much, the manufacturers might not want to make as many. So we'll quick make the demand price equation. So for this one, I'll make n number of units in thousands. P will be price in dollars. So at a price of 20, and we're talking demand at the moment, so demand of 80 in thousands, price of 16, demand of 100. So then, just like the previous problem, now we're basically just finding the linear relationship between the two. So our slope, 100 minus 80 over 16 minus 20. So we have negative 20 over negative 4, which is positive 5. Minus 80 is positive 20. I was wondering why that looked strange. So negative 5. My apologies there. Positive 20 over negative 4 is negative 5. So we have a slope of negative 5, and we'll go ahead and continue that on the next page here. So then change in the output is slope times the change in input. So n minus 80 is our slope times p minus 20. So n is negative 5p plus 100 plus 80. So I distributed and added 80 to both sides. So then n is negative 5 times p plus 180. This would be our demand price equation. So see if you can kind of pause it for a moment and find the supply price equation. Same parameters as before. Okay, welcome back. So at a price of $20, our supply was 100 in thousands. At a price of $16, our supply was 70 also in thousands. So we find our slope, 100 minus 70 over 20 minus 16. So 30 over positive 4. So 15 halves. So then change in the output. We'll just use the one with prettier numbers. N minus 100 is slope times change in input. So 15 halves of p minus 20. So n is 15 halves of p. Positive by negative is a negative. Half of 20 is 10. 10 by 15, 150. And we'll add 100 to both sides as well. So n is 15 halves of p minus 50. So that is our supply price equation. And putting that with our supply demand equation, we can also find an equilibrium point. So our equilibrium point, supply and demand are equal. We can just think of this as a little 2x2 system, 2 equations, 2 variables, and just use substitution to solve it. So our demand is n equals negative 5p plus 180. Our supply, n equals 15 halves of p minus 50. So by substitution, 15 halves of p minus 50 is worth negative 5p plus 180. Let's see, we can kill the fractions and call this 15p minus 100. So we're just multiplying both sides by 2 is negative 10p plus 360. So 25 times p. So I added 10p to both sides, add 100 to both sides is worth 460. So P is 460 over 25. Now this one, since P is a price in dollars, it would make sense to approximate this in decimals, although we won't be doing that in general for just plain number problems. If it is a dollar and cents problem, typically we would round to the nearest hundredth. So then our P is equal to 18.4, so that means the equilibrium price, $18.40, and then you sub that into either of these to get the end value. So plug it in, it's TI or Hewlett-Packard or whoever your calculator manufacturer is after that. We'll plug and chug and we get an 88. So the equilibrium point is 88. Remember, that's in thousands, so 88,000 units. And a price of $18.40 each. So that's when supply and demand will even out for us. All right, so hopefully the linear stuff is just a quick basic review for you. Quadratics also in this section. The basic format of a quadratic function, f of x is ax squared plus bx plus c. And if this is quadratic, there's one value that is definitely out of bounds for a. Can you think of it? Hopefully you came up with 0. A is non-zero. If a is worth 0, f is not a quadratic function. 0 times any value is 0. That would drop that entire term, and f would be linear, not quadratic. And for this book, we'll assume a, b, and c are in the set of real numbers. So our y-intercept is at 0, c. All y-intercepts happen when x is 0. If x is 0, that drops our first pair of terms. X-intercepts, if any, we get our we would set our f of x to 0 and solve, and we can just use the quadratic formula then. So our zeros would be x equals opposite of b plus or minus square root of b squared minus 4 times a times c over 2a. So then our intercepts, if they exist, would be opposite of b plus root b squared minus 4ac all over 2a, and 0 for the y, also opposite b minus square root of b squared minus 4ac all over 2a, and 0 for the y. If we have a negative underneath the radical, that kicks us off the real numbers, which means we're not touching the x-axis. Remember, the x-axis and y-axis are real number lines. So we have the square root of a negative, we're off of the real numbers. Hence not in the xy plane anymore, so not an intercept. So for example, if we have f of x is x squared minus 6x plus 10, our y-intercept, we just find f of 0. F of 0 is 0 squared minus 6 by 0 plus 10, which is 10. So we have 0, 10 for y-intercept. X-intercepts, if they exist, we would find the value for opposite of negative 6, so positive 6, plus or minus square root of 6 squared, 36, minus 4 times 1 times 10, all over 2 times a is 1. So 6 plus or minus square root of, we have 36 minus 40, we have a negative under that. So we have no x-intercepts. Hopefully you remember from your college algebra days Since a is greater than 0, this opens up. Hopefully you also remember from your college algebra days how to find the x-coordinate of the vertex. That is just the stuff in front of the square root on the quadratic formula. So x equals opposite of b over 2 times a. And then f of opposite of b over 2a. So f of 3, we have 9 minus 18 plus 10. So those are just plugging in 3's for the x's. So f of 3, negative 9 plus 10 is 1. So 3, 1 would be our vertex. So it should make sense that if our vertex was above the x-axis and we were opening up, that we didn't have any x-intercepts. We might be asked to find the pointer points of intersection. And if we have two functions given, we'll do, my apologies there, x minus 3 quantity squared plus 1, and g of x equals 7. If I want to find where two functions meet, just set one equal to the other. So x minus 3 quantity squared plus 1 is equal to 7. This one is set up for just completing the square. Or we don't even really have to complete the square, so just the square root method. So x minus 3 quantity squared is 1. Square root of both sides. Remember, when you take the square root of both sides of an equation that didn't have one, you need a plus or minus involved. So x minus 3 is plus or minus root 6, so x is 3 plus or minus root 6. And to find the y values that go with that, you can plug them into f of x or into g of x. Can you spot which one would be easier? Not that either of them would be super difficult, but one's definitely easier. G of x would be easier because no matter what I plug into g of x, my output is 7. Notice that does fit with what's happening with f of x. We have the 3 plus root 6 minus 3, the 3's drop. We have a square root of 6 squared, which is 6. 6 and 1 is 7. So it does work out. So our points of intersection, 3 plus root 6 comma 7, and 3 minus root 6 comma 7. So if we want to know where they meet, set one equal to the other and find the ordered pairs. So continuing this example on what interval or intervals is f of x greater than g of x. Well, we know the x intervals where they are the points on the x-axis where they the functions will meet. So basically we can just kind of look at the shadow of this function. We know that at 3 minus root 6 and 3 plus root 6 the outputs were the same. So we can just use guinea pigs, some test points. So we can try x equals 3 in the middle. Root 6 is a little smaller than root 9, a little bigger than root 3, so it's 2 and change. So anything bigger than 5 and change, so maybe, I don't know, 10. And 3 minus 2 and change would be 1 and change, so maybe a 0. And we just figure out which one is higher, which one is lower. So f of 0. 0 minus 3, negative 3. Square that is 9. 9 and 1 is 10. G of 0 is 7. F of x is greater than g of x on this interval. Trying out the 3. 0 squared plus 1 is 1. F of 3 is 1. G of 3 is 7. f of x is less than or equal to g of x there. So we don't want that piece of graph. And trying out the 10. 10 minus 3, 7. 7 squared, 49, and 1 is 50. So f of 10 is 50. G of 10 is 7. F of x is greater than g of x on that interval. So on what interval or intervals is this true? This is true on negative infinity up to but not including 3 minus root 6. And we'll union that with 3 plus root 6 to infinity. So since we already knew where they met, we just cut the number line up and use some test points to find out which one we're interested in. All right, so the next up, we'll look at graphing by completing the square, a little mini review on that. Ran another pen out of ink there. There we go. All right, graphing by completing the, a little hard to read there, square. So this is, if I recall, not necessarily the favorite topic among college algebra students. So we'll take a quick run through this, completing the square. So we'll take a look at f of x is x squared plus 8x plus 9. So we want it in that nice, pretty easy to use format where we have f of x is a by x minus h squared plus k, where we know then, okay, if we've completed the square, the vertex is at hk, opens up if a is positive, down if a is negative. Quick, easy sketch. So we just get it to that form. So first I kind of regroup it. I just sort of scooch my plus 9 over. We want to make sure the leading coefficient is 1. It is. If not, we have a little factoring to do. Then we want to do half of the middle coefficient and square it. Half of 8 is 4. And square the result. We're always allowed to multiply by 1. We're always allowed to add 0. 16 minus 16 is 0. We have added 0. So we change the look, but we don't change the value. So an f of x, x plus 4 quantity squared minus 7. So now we know our vertex is at negative 4, negative 7. So we shifted left 4, down 7. A is greater than 0, so that opens up. A is equal to 1, so no stretching or shrinking. Compression, if you want to call it that. And our vertex is in Q3 and we're opening up. That means I do have x-intercepts. Y-intercepts, that's easier in the original version. F of 0, 0 squared plus 8 by 0 plus 9 equals 9. So 0, 9 is our y-intercept. X-intercepts. We can go with the second version. 0 is x plus 4 quantity squared minus 7. So 7 is x plus 4 quantity squared. Square root of both sides, plus or minus on the side with a constant. So plus or minus root 7 is x plus 4. So x is negative 4 plus or minus square root of 7. So there's our two x-intercepts. So negative 4 plus root 7, 0. -4 minus root 7, 0 as well. And that should be enough to make a nice pretty sketch. Okay. All right, so our vertex, -4, -7, left 1, 2, 3, 4, and drop down 7, so 2, 4, 6, and 7. That also indicates for us where the line of symmetry is. So 1 unit away, 1 squared is 1. 2 units away, 2 squared is 4. 3 units away, 3 squared is 9. We're at -7, so now we're at a +2. Our y-intercept at 0, 9, notice that does fit in with 4 units away, you would go up 16 units. And a nice smooth curve, arrows on the end. And notice we didn't have x-intercepts at lattice points. That's okay. Square root of 7, a little bit bigger than square root of 4, a little bit smaller than square root of 9. So it's 2 point something. So -4 minus 2 point something is -6 point something. -1, 2, 3, 4, 5, 6 point something. Same deal over here with the -4 plus 2 point something. So -1 point something. And again, hopefully most of that is a little bit of a review. This next one, I'll just do a quick review of, again, sketching by completing the square, but this time we'll have a coefficient. So we'll do g of x is half of x squared plus 6x plus 18. So I still do the regrouping of sort of just moving the constant a little bit further down the line, but I'm not going to do half of 6. I need a leading coefficient of 1 to get there. So what I'm going to do is factor a half from those first two terms. So half times 1x squared is half x squared. Half times 12x is 6x. So remember, dividing by a half and multiplying by 2 are the same idea. Plus 18 is going to go on the outside. Now I'm ready to complete the square inside of here. So half of 12 is 6. 6 squared is 36. I'll write a plus 36, but remember what that's worth. Don't forget we have this 1/2 out here. So that plus 36, half times 36, what I really did was added 18. So I will also subtract 18. So then g of x is half of x plus 6 quantity squared, and 18 minus 18 is worth a 0. So just some key facts of this that we can tell. Our vertex is at -6, 0, so it's sitting right on the x-axis. It is opening up since a is greater than 0. A less than 0 would open down. Absolute value of a is less than 1, so this is compressed. Vertical compression. We already know our x-intercept since it is also our vertex, and we know we only have one of those, so -6, 0. Y-intercept, again, I would go to the original version, plug in zeros for here, you'll get an 18. So the y-intercept isn't going to quite fit on our usual -10 to 10 grid. So then that's enough to make a decent sketch, particularly that we know the a value as well. So I'll go to my -6, 0. Which also gives me the location of my line of symmetry. It's opening up, but half as fast as it would. So 1 squared is 1, half of 1 is a half. So we'll go a unit out and only up a half a unit. 2 squared is 4, but half of that is 2. 3 units out, 3 squared is 9, half of that is 4 and a half. My apologies. Please disregard that one. There we go, 4 units out, 4 squared 16, half of that is 8, so I can go up 8 units. And 4 units this way, I'm up 8 as well. So that does confirm what we suspected, that we wouldn't be able to see our y-intercept on this nice, neat, pretty -10 to 10 grid that we've got. All right, so on section 1.3, I would recommend trying out 1 to 55 on the odds. I'll also upload the author's just sample 1.3 homework as well for the My Math Lab fans. If you have any questions, please get in touch with me. Otherwise, I will see you next time. Stay safe out there.